In problem 5, we need to determine which of the sets from A through E are equal to each other. Set A is given in roster notation 0, 1, 2. Let's take a look at set B. B is the set of all x, element of R, which is the set of real numbers, such that -1 is less than or equal to x, which is less than 3. Because x is a real number, I can't write this in roster notation. I'll have to write the set in interval notation because we're including all the real numbers from -1 to 3, including the -1, but not the 3. I use the bracket to indicate that we're including the -1, and we go to 3, and there's a parenthesis, which means the 3 is not included. But I know that a number such as -0.7 is an element of set B because it's in that range from -1 to 3. All right. Now let's take a look at set C. Again, x is a real number, but we've lost the or equal to part underlining the less than symbol between the x and the -1. Again, I'll use interval notation because, again, we're working with a set of real numbers, or the set of real numbers. But now the -1 is not included. So we're going from -1 to 3. Again, I could say that -0.7 is an element of C because we're starting immediately after -1 and we're including all the numbers all the way up to just before 3. So we have -0.7 is an element of C. Neither of those sets B and C then could be equal to set A, which does not contain that number. Let's take a look at set D. D is equal to the set of all x in the set of integers such that -1 is less than x is less than 3. I'll write this in roster form because we're working with integers. X cannot be equal to -1, so the smallest integer it could be is 0. And then 1 or 2, and it has to be less than 3, so I stop there. This means that A is equal to D. So we know that sets A and D are equal, and that's all we have so far. Now let's take a look at set E. This says the set of all x in the set of positive integers. Notice that it's the set of positive integers because there's a little plus next to the z. Well, let me see. Oh, erased a little bit too much. I'll just leave it there. Okay, so let's see. So x is a positive integer, again, between -1 and 3. When I write this in roster form, then x could be 1 or it could be 2. It can't be 0 now because x has to be a positive integer and 0 is not positive. This means that E is not equal to A or D, so we can only say that A is equal to D. The rest of the sets are different from each other. None of the other three are the same as each other. So that's my final answer.